Right, well, beginning our discussion, I want us to run through this paper together from the first question to the last question. It's a full paper review. So I know that obviously I have two metrics here, and I'm sure therefore that um, we shall do very well. Okay, so stay put. It's a preparatory exam 2023, mathematics paper one, and it's written in 3 hours, 150 marks. And we look at the first question. The first question obviously is about solve for x, and that is the universal approach. We're going to be solving all the questions quickly. From the first one to the last, the question one had just 24 marks about on multi-answer questions that involve the log and some other general things. Let's look at the first question first. Right, the first question is about solving for x in a situation like this. We actually here can look at these in two different ways. So you have actually obviously twice x plus 1, and this is all squared minus 2 squared equals 0. How do you do this? So we recall the difference of two squares, of two squares. How do we deal with the difference of two squares? If we have a squared minus b squared is always the same as a minus b into a plus b. And hence, at this point, you would have a 2x plus 1. Then we put the minus 2 into. Then we have a 2x plus 1. Then we have a plus 2, and this equals 0. Right, so is a difference of two squares. You first put a minus and then a plus, or you can first put a plus, then a minus. So at this point, this is 2x minus 1 into exactly 2x plus 3, and this equals 0, which means x is equal to 1 over 2, or x is equal to minus 3 over 2. Okay, so that becomes exactly the answer. So 1/2 into minus 3 over 2. The next question. Right, once they say correct two decimal places, so you need to note that you need to first organize the terms. To organize everything here, that will exactly become 4x squared plus 12x minus 11 equals 0. And x becomes here minus b. So you write down the formula plus or minus the square root of b squared minus 4ac. And all these here is divided by twice a. Right, so we continue to solve this. So it's minus the b would be actually minus 12 plus or minus the square root of the b squared, which is going to be exactly 12 squared minus 4. The a is 4, and the c is minus 11. And this is actually divided by exactly twice a, and a here is the number 4, the coefficient of the quadratic term. And if we solve this here, we realize that x is approximately, if you use a calculator, minus 3,74, or our x is approximately 0,74, and these will be the answers to this particular question. Correct to two decimal places there. Okay, next question. Right, to solve this particular question, we learn how to solve quadratic inequalities. And we have these as follows. You can move all the terms to the other side of the inequality. And if you do that, you will have, first you write 9x squared, which is this one, minus 15x plus 4. Once you have moved everything to the other side, everything is going to be greater than 0. Okay, so we have exactly this here. Right, and we need to factorize this. So to factorize this here, we have these greater than 0, which is 3x, and then it is minus 1, minus 4. And so at this point, when you get to these, which means therefore you have that x is actually, if you look at the associated have here, you would realize, therefore, that you have two critical values and it has a minimum vertex. Okay, so we have that there are two critical values. 1/3 is going to come from this, and here you're going to have 4/3. All right, at this point, you put here, you exclude the intercept with the axis, and this is our x-axis. And now we are looking at where this is greater than 0. Greater than 0 is when we are above the x-axis, and we are above the x-axis, and therefore x is going to be actually clearly less than 1/3, or x is going to be clearly bigger than 4/3, and that is the answer. Now we look at the next question. Right, so we have solved the quadratic inequality. I'm just revising this concept because this is an extremely important one. Greater than 0 is what this says, but when they don't say greater or equal to, if they would have said equal, would have shaded. But since the inequality is a strict inequality, because it's strict, we actually only put open circles there. Okay, we continue then with solving more problems. Another question that we must be able to solve is how to solve for x in problems that involve things we call radicals. Right, so dealing with radicals, what do we do? Right, if you have two radicals like this, you need to actually strategize and realize that you have 2x minus 2, and you move one radical to the other side of the equation, and it becomes 7 minus 2x plus 1. So we always do this. Right, so if you have two radicals, move one radical to the other side of the equation, and then immediately what you do is you begin squaring both sides of the equation. And what we get here is that we have 2x minus 2. If you square this one here, you square the square root, it becomes 7 minus 2x. The next thing is this times that, which is actually plus 2 into the square root of 7 minus 2x until you now square the 1, which becomes a plus 1. Okay, this is true because if you have a plus b and you square this, it is actually a squared plus 2ab plus b squared. So this is what you get. So at the end, you move this one to the other side, so it becomes 4x. Then now you add everything here. You have 7 plus 1, which is 8. You move it across, it becomes exactly minus 10. And this is actually equal to 2 times the square root of 7 minus 2x, like this. You then proceed to divide through by the number 2. And if you divide 4 by 2, it becomes 2. Dividing 10 by 2 becomes a 5. And this becomes the square root of 7 minus 2x. And now what do we do at this point? We actually proceed to square both sides of the equation. And if we square both sides of the equation, this is the step we get at this point. This is 4x squared. Right, so you have 2x times 5, which is minus 10 by 2, which is minus 20, minus 20x plus 25, which equals 7 minus 2x. So at this point, then you have 4x squared, right, minus 18x, right, plus 18 is equal to 0. And at this point, you divide through by the highest common factor, 2, and you get 2x squared minus 9x plus 9 equals 0. And this is what you get. At this point, we factorize this one. The factors are 2x and minus 3 into x minus 3. And this is equal to 0. You divide your page or your screen, and x therefore becomes 3, or x becomes 3 over 2. All right, and now always please, okay, in the exams, when you square both sides, there will always be rejected solutions. And so at this point, we say that this one is not applicable. Why is it not applicable? It is not applicable because substituting into the equation will then remove or eliminate, will that rather make this equation false, and therefore we only accept these, because if we substitute this one to the original, the left is going to be equal to the right, but this one here, rather, yeah, the 3 is going to make the left and the right equal, but the 3 over 2 is going to make this equation false, and therefore it is not applicable, or we say it is actually in right, so it is actually inadmissible. It is an inadmissible solution. So we do this and we proceed. Right, inadmissible. Right. Next question. Right, so we need to solve this one simultaneously, and therefore we get the answer. What is the answer to this particular? So these are simultaneous equations. Right, to solve these simultaneous equations, so the first things first, we proceed as follows. Right, this one can be solved with ease because it involves the log. So which means that if you remove the log, you exponentiate, so it becomes 2 to the power 3, which means a is 2 to the power 3, which is 8 minus 5. What is 8 minus 5? It is actually a 3. And we have got the numerical value of a, and then we want to get the b. So we substitute b into the other equation. So which means a is 3 squared, b squared minus 2a is 3 here, times b minus 8 equals 0. And then this becomes exactly 9b squared minus 6b minus 8 equals 0. And at this point, what do we have? We have exactly these here. And then we need to write down the factors of this. What are the factors of this? Right, the factors of this expression can be seen clearly. So it is 3b minus 4. It is 3b plus 2, which means b is equal to 4 over 3, or b equals minus 2 over 3. And these are the two answers to the question. Right, so these are the solutions. A is 3, b equals 4 over 3, or b equals minus 2/3. The next question, please. Right, we're looking at how to solve quickly a question of this form here, involving the radicals as well, for which the values of x for which values of x will p be real. Right, so first things first, to solve this one, we have to look at the fact that the numerator x plus 2 must be greater or equal to 0, which means x is greater or equal to minus 2. Or obviously, we also have another result. So simultaneously, these must be true. So we always, if these are coming from the same expression, we say this must be the case, and the other one must be the case. These conditions must be met simultaneously. So which means 16 minus x squared must be greater than 0. The denominator cannot be equal to 0, because why do we say it's greater than 0? Because we are dealing with terms under the square root sign. We do not take square roots of negative entities. So the square roots that we take, either the entity must be 0 or it must be greater than 0. Okay, we take the square roots of positives because it's only at university or technical mathematics that you can take the square root of negative number up there, and because the square root of -1, for example, at university becomes the imaginary number I. Right, imaginary. So at this point, now you need to deal with this, and you need to quickly factorize this. Right, so what is 16? 16 is 4 squared. X squared is greater than 0. Right, so again, we remember from grade 10, the difference of 2 squares. Okay, I'm going to be really obviously trying to solve this question so at a faster pace a little bit. I know that this is very easy for you, but you need to just be reminded. So it's just revision. At this point, what do we do? So we need to draw the graph here. So we know that this graph is going to have a maximum vertex, please. Why a maximum vertex? It's going to have a maximum vertex because of the fact that we have the coefficient of x squared is quadratic, or rather it's negative. So which means that it's going to have a maximum vertex. Okay, make sure that you look at the coefficient. And if it's negative, your graph is going to have a maximum vertex. And then now you have this one here. You have this one is -4, and this is +4, and this is at x. Okay, look at this carefully and think of this. If this is greater than 0, you need to look at the fact that right, it is not equal to 0, so you need to put an open circle here, you need to put an open circle there. Right, greater than 0, you actually obviously look at the part that is certainly above here, greater than 0, which means therefore -4 is less than x less than 4. You will have therefore that the values of x are satisfy this and make this true, those values of x that are between -4 and 4. And therefore, we draw a number line like this, and we put the number line of the x values, because this and this must be both satisfied. So we put -4, we put -2, and we put 4. Right. So at this point, you sketch this one on the number line. So you put open circles. So it is exactly like this. Okay. All right. Um, so we continue. Um, we continue. So right at this point, so you have this. So now at this point, then you have x here is greater or equal to -2. So greater or equal to -2, you would look at -2. Now you go to the greater side, and therefore right now you need to look at where these two overlap. So they will overlap between here and there. And the final answer, therefore, is actually that you have -2 and 4. The x lies between those two, and you have this, but equal to -2 there, and the x less than 4, and therefore that is the answer to the question. So you know, you take note of right, right. Um, um, okay, that is the answer. Um, right, so we continue. So now we look at the next one. Right, we look at the next one. Let's look at 1.3.1. The following is an arithmetic sequence. So you have the question on sequence and series, and here are the questions. There are a lot of them, but I have broken them down into digestible pieces. So 60 marks about on sequence and series. Some are quadratic, some are arithmetic, etc. Now let's look at the first question. The following is an arithmetic sequence, and it's given in that form. Right, so calculate the value of p. Right, if they say it is arithmetic, they actually immediately you must note that term2 minus term1 is equal to term3 minus term2, and these things here, they give a common difference. Right, so and therefore, what is term2? It is 2p minus 3. Term1 is 1 minus p. Term3 is p plus 5. And term2 is actually twice p minus 3. And therefore, what is this? It is twice p minus 3 minus 1 plus p. And this is p plus 5 minus twice p plus 3. Okay, and then we group everything together at this point. Right, what is 2p plus p? It is actually 3p. You subtract 4. And this one here is actually equal to minus p plus 8. And we transpose these things here to give us 4p is equal to 12. And now you have p is equal to 12 out of 4. And we have p is 3. So calculate the value of p, and therefore we have that p is 3 in the arithmetic sequence. Okay, the next question. Right, the following is still the arithmetic sequence we saw. We need to write down the value of the first term of the sequence and the common difference. Okay, what is the first term of the sequence? So in part A for the first term, you'd remember that the first term is also called T1, which is 1 minus P here. That is the first term, but we know from the previous question here that P is equal to 3. So we recall that P is 3, which means it is 1 minus 3, and this is minus 2. In the part B, we want the common difference. We have already said the common difference is the second term minus the first term. What is the second term? Is 2p minus 3, which is minus term 1, which is 1 minus p. And what is this exactly? So it is twice p minus 3 minus 1 plus p, which means it is 3p minus 4. And it is 3 into p. P is 3 here, minus 4, which is exactly 9 minus 4. And 9 minus 4 is equal to 5. And therefore, the common difference here at this point is actually equal to the positive number 5. And we are done with solving this question. And we proceed to do the next one. Right, the next question focuses on explaining why none of the numbers in this arithmetic sequence are perfect squares. Now, let's look at these in TPN 1.3. We would look at the sequence, which is 1 minus p and twice p minus 3, and then p plus 5, etc. You have that, you have 1 minus 3, you have twice 3 here, minus 3, you have 3 plus 5, and you continue. So this is actually minus 2 here. This is exactly 6 minus 3, and 6 minus 3 becomes 3, and this becomes 8. Right, and in particular, you can be able to see what is happening here. Right, you can extend because you already have the common difference. The common difference is 5. So you can expand this and realize that if you add 5, you get 13. You add 5, you get 18, and so on. So all the terms except T1 end in either 3 or 8. Right, so we note that all the terms except T1 end in either 3 or 8, while perfect squares and while perfect squares end in 1, 4, 9, 6, 5, 0. So you have that. Alternatively, a student can say also, or you can look at the fact that Tn is a plus n minus 1 times the common difference. and realize that the first term is going to be minus 2 here, plus n minus 1 into the common difference. So we have seen that the common difference is the number 5 of this sequence. And this is minus 2 plus 5n minus 5. And this is 5n minus 7. And this is not a perfect square. Not a perfect square. So that in the end, then, if this is not a perfect square, it explains why none of the numbers in these arithmetic sequence are not perfect squares. But also perfect squares ordinarily end in 1. They end in 4. They end in 9. They end in like 16 is a perfect square because it ends in 6. 25 is a perfect square because it ends in 5. 100 is the same as 10 squared, which is a perfect square because it ends in 0, etc. 121 is a perfect square because it's 11 squared, it ends in 1, and so on. Okay, so next question. Right, so the following sequence of numbers forms a quadratic sequence, and therefore we are answering the question. The first differences of the above sequence also form a sequence. Determine an expression for the general term of the first differences. So you have minus 3 here, you have minus 2, you have minus 3, you have minus 6, you have minus 11. So you have this here. And therefore, if you subtract this minus that, you get a 1, this minus that. You get a minus 1, this minus that. You get a minus 3, minus 11, minus into minus 6 is minus 5. Subtracting these quickly, you get a minus 2, you get a minus 2, you get a minus 2. Right, so what are the first differences? So these are the first differences. Right, here we're dealing with the first differences. Right, so dealing with the first differences, it means a couple of things. Right, what does it mean? Because the first difference of the above sequence also form a sequence, determine expression for the general term. So which means that we know that this one, so the first differences, they form in, because the original is quadratic, the first differences form in arithmetic sequence, but always, if they form an arithmetic sequence, the general term is this one here. Tn, what is the first term of the first differences? Right, the first term of the first differences is the number 1 here. In minus 1, the common difference of the first differences, if you find the common difference of the first differences, it is minus 2 there. And if you expand this, it's 1 minus twice n plus 2, which means twice n is actually 3 minus twice n. Right, so it's exactly this one here. We were to find a general term. It can also be written as minus twice n plus the positive number 3. Okay, next question. Right, the following sequence of numbers forms a quadratic sequence like we've seen. Calculate the first difference between the 35th and the 36th terms. Right, so if you look at these very carefully, you need to understand this. And so I'm trying to teach now how you deal with the terms they pick, the differences they pick, and they pick them very randomly. So how do you deal with that? Right, first we find some of these to understand what is happening here. And so the difference here is 1, here it's minus 1, here is minus 3, and here is actually minus 5. You find the difference is also there. And this one is minus 2, this is minus 2, and this is minus 2. These are the first differences here. Right, so if you find the first differences, so these become the second differences. Right, so if you are dealing with these differences here, in 2 to 1, so if they say calculate the difference between the 35th and 36th terms of the quadratic sequence. So what is the difference between the first and the second? The difference between the first and the second is the first term. So the difference between the first and the second, it's the first. Between the second and the third, it becomes the second. Between the third and the fourth, it becomes a third term. Between this one, 2, 3, 4, between the fourth and the fifth, it becomes the fourth. So between 35th and 36th, it will become 35th. So we use the formula we got from the previous question, which is Tn equals minus 2n plus 3. So Tn is minus twice n plus 3, which means that at this point you have T35. So because it's a quadratic sequence, it's between T35 and T36, you find T35. Because if you want to find this first term, you must you must realize that it is actually this term is the first term between these two. If you want to find the second term, you realize that it is actually nothing other than this second term. It relates to, it's between the second and the third, so it's the second. Between 35th and 36 is 35. And therefore, it is minus 2 into 35 plus 3. What is this? Here is minus 70 plus 3. What is minus 70 plus 3? Is minus 67. And therefore, which is T35. Okay, so we get the answer to this. Next question. Right, so in 2, the following sequence of numbers forms a quadratic sequence, which is minus 3, minus 2, etc. Determine expression for the nth term of the quadratic. Okay, that one you know very well. It's just run through it, just to make sure that you just have some revision on how quickly this one can be done. Right, so you find the difference here. What is the difference here? The difference here is 1 minus 1. It is minus 3, and it is minus 5. Okay, so you continue also, you find these differences, and they are minus 2, minus 2, minus 2. There are a couple of things you need to note, that this one is always 2a equals this one. This one is always 3a plus b equals this one. This one is always a plus b plus c equals this. So, and hence here you have 2a equals minus 2, which means a is minus 1. Right, so it means at this point here, you have what? Right, so you have got the value of A, and you just need to get the value of B and then the value of C. So this is true, and you have that the 3A plus B, so you have 3A plus B is equal to 1. 3A is minus 1 plus B is 1. What is B? Okay, 3 times minus 1 is minus 3. You add, it becomes 4. And what is next? A plus B plus C is the first one. So A plus B plus C is minus 3, which means A is minus 1, B is 4 plus C, which equals minus 3, which means that C is actually a 3 here, which means that it is a minus 6 there. So as a consequence, what we are achieving is that Tn is actually an squared plus bn plus c, which means that you have a is minus n squared plus 4n because b is 4 and the c is minus 6. And therefore, now they said determine expression for the nth term of the quadratic sequence. So we deal with the quadratic sequence like this. So we find our a, our b, our c, and we substitute everything there. All right. So we have got the answer to 3 or 2.2.3. We look at the next question, 2.2.4. Right. Show that the sequence of numbers will never contain a positive term. Right. So we proceed as follows. Right. So we continue to do this one. In 2.4, would remember that from the previous question, the general term is minus n squared plus 4n. Here, minus 6. So we remember that t subscript n is actually minus n squared plus 4n minus 6. We can find the derivative of this one here, like this, which is actually the same as if we look at these, can look at these as sort of a function of a function. So we are dealing with this one, which is a t of n, which is minus n squared plus 4n minus 6, which means it is t primed of n, which is minus twice n plus 4. And we get the answer. We must equate this one to 0 because it is a graph that sort of will tend to have a max vertex. Why a max vertex? This is a quadratic function that has there's a maximum vertex because a is negative 1. A is negative, it has a maximum vertex, so we equate it to 0 at the maximum vertex at the turning point. In which case, we can solve for the n. What do we do to solve for n? So it is minus 4 divided by minus 2, which equals 2, which means that 2 of 2 here, it is minus into 2 squared plus 4 into minus that, which means therefore, in the end, you would realize that t of 2, if you simplify everything, this is actually the number minus 2. And remember, therefore, that this is the biggest value. So it is the maximum value. And therefore, we can conclude that we have no positive terms because the biggest one is a negative 2. Um, so if ever positive terms were there, the positive one would be the biggest. If the biggest is a negative number, it means the others are negative numbers as well. So, and hence these will never contain a positive term because we're to show that the sequence of numbers will never contain a positive term. And therefore, we have that minus 2 is the maximum. And if a negative number is the maximum, it means that there are no positive numbers in this because this calculus method helps us find the biggest number. And this says the biggest number is a negative 2, meaning it means that there are no positive numbers because a positive number would be bigger than any negative number anyway. Okay, we'll look at the next question. Right, so if you look at question 3 right now, we are looking at these summation and want to find term 6. Here we're looking at a series that is convergent. And here we're looking at the sigma notation here. So looking at these things here, we proceed as follows. Given that Sn is this, find term 6. Okay, if you're given the sum formula and you have to find term 6, right, a term, so you must take the sum of the first 6 terms. From the 6 terms, so you subtract the first 5 terms, right? Dealing with the 6 terms here, you would have 4. Here's the formula. You'd have 4 into 6, so you square plus 1, and then you subtract here 4 into 5, you square, you add 1 to that. which means T6 is equal to, okay, let's find the sums here. Okay, if you add everything here, this one is 145. This one here is 101. And then we find T sub 6, which is exactly the number 44. So in other words, we have found T subscript 6, which is 44, by saying the sum of the first 6 minus the sum of the first 5 terms. We proceed to the next question. How do you now, if they say for which values of x will the following series converge? Right, we must first find something we call the constant ratio. Right, the constant ratio is going to become the second term divided by the first term. What is the second term? It is 4x minus 3 squared divided by 4x minus 3. And you divide this here, it is 4x minus 3. And so now this is our constant ratio. And we know that the constant ratio R must be between -1 and 1 for the series to converge. This is the condition. So we continue now with the condition. We actually realize this here. You can add 3 to the each side here. So you have -1 plus 3 is less than 4x minus 3 plus 3 is less than 1 plus 3. And this is actually the number 2 is less than 4x less than 4. You divide through by the number 4. Dividing through by 4 is like 2 out of 4 is less than 4x out of 4 is less than 4 out of 4. And therefore, you have that 1 over 2 is less than x less than 1. Right, so at this point, we have that these are the values of x. Right, so, but now we must state a condition that we do not accept that the constant ratio be equal to 0. So we admit that we don't want it to be equal to 0 here, which means therefore the 4x minus 3 itself cannot be 0 because the constant ratio is 4x minus 3. And if you solve here, we realize that x should not be equal to 3 out of 4. And now x is here. So the final answer here, hence we have 1 out of 2 is less than x less than 1. And here x is not equal to 3 out of 4. Okay, so we have the answer to this. For each values of x, will it converge? For x lying between 1/2 and 1, and x not equal to that one there. Next question, please. Right, how do we find these? Calculate the summation here. To find this summation, we proceed as follows. So we substitute from 3 to 5, which means you have -1. You start from k equals 3, so we put 3 here times 2 out of 3. We add, so next we put 4, which means it is -1 to the 4th power, 2 out of 4. The last one is -1 to the 5th power, 2 out of 5. Okay, we're starting from 3 to 5. We're substituting wherever there is k, we substituted 3. Next, we substitute 4. Next, we substituted 5. So at this point, what we are then getting is the same as -2 out of 3 plus 1 out of 2 minus 2 out of 5. And therefore, at this point, we take the lowest common denominator. And therefore, at this point, if you take the lowest common denominator of this, you would realize, therefore, that these can be simplified with ease. And let us simplify these. If you divide by 30 by 3, you get a 10. You multiply, it becomes -20. Divide 30 by 2, you get 15 by 1, you get exactly 15. You divide 30 by 5, you get a 6. You multiply by 2, you get 12. And therefore, what is the answer? The answer is minus 17 out of 30. And that is the answer to the question. So this is how we did the sum. So this sum is tricky. It's a tricky sum because it is alternating. So is it geometric this? Is it arithmetic this? Actually, obviously, normally we use those formulas. So it's something you need to consider. But obviously, it is clearly alternating, and this was the easiest way for us to use for the summation here. Okay, we move to the next question. The next question is on graphs. Right, we have a lot of questions on the graphs. They've put two graphs here. These resembles common IEB questions. The questions in the independent examinations board exams normally have a tendency of including the rectangular parabola twice. And we are asked a couple of questions. Let's get started with solving question 4, which had 14 marks in this year's preparatory exam question paper. First things first, we now must learn how to write down the domain of the rectangular parabola. What is the domain? To find the domain, we take the denominator, x plus 3, and we say it is not equal to 0, and therefore x is not equal to minus 3. That is the domain. And we are done. Understanding is that x is not equal to minus 3, but x is an element of the set of real numbers. Right, remember we are dealing with the domain of the function g. We have nothing to do with h when it comes to the domain for this particular question and for 1 mark. Right, at this point, we must be able to write down the range of the function h. What is the range of h? The range of h is that we cannot allow y to be 2. So y is not equal to 2, but y is actually a real number. So y is not equal to 2 and y is not a real number. It's a real number. Y is an element of the real numbers, but it's not equal to 2. Next question. Right, so you have the two rectangular parabola functions. If the graph of g is shifted so that it coincides with the graph of h, so this graph is moved so that it is the same. Coincides, it is the same as this. How do you make these the same as that? That becomes the question. In the first, how many units must the graph be shifted horizontally? How many units must this g be shifted horizontally? So we will look at the answer to 4.3.1. Right, so in 4.3.1, we realize that you must shift it by some units. By how many units can you add? What number can you add to these to get to that point? So you have 6, which is x. Okay, now you can subtract 6 plus 3, then minus, okay, we're looking at only the horizontal shift, right? So horizontal shift means we only change x. So now we have at this point x minus 3 minus 3 over 2. So x minus 3 minus 3 over 2. We have shifted these graph 3 units, 6 units horizontally. So how many units must the graph be shifted horizontally? 6 units. Why 6 units? Because it is only when you subtract 6 from x that you get minus 3 here. How many units must the graph be shifted vertically? Vertical shift means what number can you add to this to get the number 2? So we are looking at, you get to this point. So you have 6 divided by x minus 3. You have minus 3 over 2. What number can you add to these so that you get to that point? Right, this is minus 1.5. Minus 1.5. So if you add, for example, a number like 7 over 2. 7 over 2. What do we get? Let's check. You have here 7 over 2 is like 3.5. Okay. So, right. So you have here 2 here. You divide this here, 1, you get minus 3 plus 7. So this is that x minus 3 And this is 7 minus 3. What is 7 minus 3? It's 4. 6 divided by x minus 3 plus 2. Okay. Surely if we add 7 over 2, we get 2 here. We add 7 over 2 to minus 3 over 2, you get the number 2. So in other words, we must therefore shift the graph. Right, so how many units must be shifted? It must be 6 units, and here it must be 7 over 2 units, which means it must be 3,5 units. Okay, 7 over 2 is the same as 3,5 units. Okay, so 7 over 2 units was added, so which means it is 7 over 2 units upwards, because you're adding. If you add to this, then you get the number 2. So it is exactly upwards. Okay, now you have the number 6. What do you do with the number 6? Right, so the number 6, it was the horizontal shift. So it was 6 units in which direction? 6 units right. 6 units to the right, because if you subtract, the graph moves to the right. So how many units must the graph be shifted? How many units must the graph be shifted vertically? So yeah, we have stated that one there. So it's 6 units and 3,5 units respectively. Next question. Write down the equations of the asymptotes of G. Right, the asymptotes of G, or the parts where the function itself would be undefined. So to get the asymptote, you say x plus 3 is 0, which means x equals minus 3. And this is a vertical asymptote. It's a vertical asymptote. And then now you have also the other asymptote, which is y for the function g, is y equal to negative 3 over 2. And this one is called the, through the y, it is the horizontal asymptote. Horizontal asymptote. Right, so we get this answer. Next question. Calculate the x-intercept of G. Right, so to find the x-intercept, what do? We are finding the x-intercept. Right, if you're finding the x-intercept, what do? You actually proceed as follows. You let y be 0. Right, the intercept here, so you let y be 0. Okay. You have this here, x plus 3. And so you have minus 3 over 2. Remember, I want to find the x-intercept of G. G is this one. This one is H. Right, so we can just move this 3 over 2 to the other side. It is negative now. It's going to become positive 6 over x plus 3. You cross multiply here, which means you have exactly 3 into x plus 3, which becomes 2 into 6. 3x plus 9 equals 12, which means 3x is equal to 9 minus 12 minus 9 is 3, which means x is 1. What is the x-intercept? The x-intercept is when x is 1 and then y is 0. X is 1 and then y is 0. X is 1 and y is 0, and that is the x-intercept of the function g, that one. Next question. Sketch the graph of g in your answer book. Show clearly all intercepts and rather asymptotes and intercepts with the axis. Let us draw the graph quickly, and it's very, very straightforward to draw graphs. Right, to draw the graph, we draw first the coordinate axis, the Cartesian plane, the vertical axis, the horizontal axis, x equal to minus 3 here. So with x equals minus 3 here, and therefore you will have this here like this. That is one part. We have seen that the x-intercept is 1. You can find the y-intercept by making actually here x equal to 0, you realize that this is 1/2, the y-intercept. Right, so how do you find the y-intercept? Right, so if you're finding the y-intercept, how do you find the y-intercept? You let x be 0, which means you would have a g of 0. Yeah, divided by 0 plus 3 minus 3 over 2, which means you have g of 0 is 2 minus 3 over 2. G of 0 is actually what? 2 minus 1.5. From 2, you remove 1.5, you're left with only 1/2, right? So this one is minus 3. And now this is having this. So you have this here, right? So you have exactly that part. So this is a sketchograph. And show all, so this one here is the minus 3 over 2. We have shown the vertical asymptote, we have shown the horizontal asymptote, we have shown these graphs here, and we are clearly done. Next question. Determine the value of k if h of x is an axis of symmetry, right? So if we're dealing with the axis of symmetry or the line of symmetry, we need to look at the fact that the axis of symmetry passes through. Right, so it passes through the following, right? So it passes through where you have x is minus 3 and y equals minus 3 over 2, which means, therefore, that h of x is this here. So when h, then you have minus 3 over 2, you have minus 3 plus k. Right, and therefore, what is this here is minus 3 over 2, which equals 3 plus k. And so what is the value of k? So the value of k becomes exactly the same as minus 3 over 2, then minus 3, which means that is 2 times minus 3 minus 6, which is minus 9 out of 2. And therefore, right, that is the final answer, right? To determine the value of k, if this one is an axis of symmetry, so the value of k is minus 9 over 2. The axis of symmetry will pass through the two values there, this point of intersection of the asymptote. But yeah, the graph has been drawn. I can just give a comment about the lines of symmetry. The lines of symmetry would be a line of symmetry that passes through here. Symmetry means that it divides the graph in space into two identical sections, and you'd have another one that runs straight up with a positive slope there. Okay, next question. For which values of x will this one be the case? Right, we analyze this one in 4.8, right? So you would need some analysis of the graph very quickly. Right, so I'm gonna sketch the graph here very, very fast. And we have this here, it cuts through the number minus 3. And also it cuts through the number minus 3 halves. We have seen that here. And therefore you have these here is this, which means that you have here, this one is 1/2, and this one is 1, and this one is like this. So what do we need? So now this is the graph we saw. We want to actually be in a position to find the answer to this question using, because it involves an inequality. So we are effectively looking at this. The 6 out of x plus 3 minus 3 out of 2 is bigger than minus x plus k. Look at this. It is the function g, which means it is g of x is bigger than minus x plus k. So what is the answer? So we're looking at whether function g is bigger. It's actually above this line of symmetry. So the line of symmetry with a positive, with a negative slope, I said will run like this. But for what value of x will we have a situation where the graph itself is above this line here. It is above the line at this point. This is the section of the graph that is above. So it means that for what values of x, okay, so clearly it is for x bigger than -3, because when x is bigger than -3, we have a situation where this graph is above there, okay? So x is bigger than -3, this graph is surely above over there. Okay, next question. The graph of G is reflected in the x-axis. Okay, write down the new equation. So we speak of a reflection. I'm going to give a general rule here. Reflection in the x-axis. Right, reflection in the x-axis means what? Means that a point xy, okay, if you look at what happens in the plane, this is the coordinate system, the Cartesian plane. I take a point here whose coordinates are x and y. I reflect it to a point here, and this one is going to become what? X is going to remain the same, but y is going to become negative. So this point is going to be transformed into x is going to be there, then y is going to become negative. So at the end of the day, right, the graph of G is reflected in the x-axis. Write down the new equation in the form that. So the new equation is that y is going to become negative in G. So we have therefore that y is G, or G of x is actually y, which equals 6 over x plus 3, and this is minus 3 over 2. And then you have that y itself is now negative, and it is 6 over x plus 3 minus 3 over 2. Okay, if you want to solve for y, which becomes minus 6 over x plus 3, you divide here, which is plus 3 over 2. Right, so this is what we get. So now the graph of G is reflected in the x-axis. Write down the new equation in the form y equals this. It is actually minus 6 over x plus 3 plus 3 over 2, and that is the answer. Next question. Right, if you look at the graph here now, there's another graph, which is the rectangular parabola, but also you have a straight line graph that has been given. The graph has been drawn here for us, and we need to write down the coordinates of the turning point. Let's get started with the questions. Right, you need to write down the coordinates of the point E. E is the turning point. What are the coordinates of the turning point? So the point E, which is the turning point, will clearly have coordinates 7 over 2 and 81 out of 4. And that is exactly the answer. 7 over 2 and 81 out of 4, that is the answer. This is the turning point for 1 mark. There it is. Next question. We need to be able to find the average gradient. Please, IUP students, watch average gradient because it's already there. Tomorrow, they're going to ask you the average gradient. How do you find the average gradient between 5 and 1 and 5? So you'd say average gradient, right? So you say average gradient is the same as f of 5 minus f of 1 divided by exactly 5 minus 1. So what is f of 5? Okay, you substitute here, wherever there is x, you put 5, okay? And if you do that, how do you do that? You say f of 5, in the here, you have minus into 5 minus 7 over 2, you square that, plus 81 out of 4, you get the answer. The answer to f of 5 is going to be exactly 18. And then if you do f of 1, wherever there is x, you put 1 there. Yes. You square these plus 81 out of 4, and then you get a 14. So f of 5 is what? It's exactly 18 minus 14 divided by 5 minus 1, which is the same as what? Which is exactly the same as 4 divided by 4, which is 1. What is the average gradient? The average gradient is equal to 1, and we are done. Next question. Right, we need to also be in a position to do calculations, like calculate the value of A. And the value of A here is the x coordinate of the point D. How to find the x coordinate of the point D? Right, so note that the pointer D is obviously a pointer that is, so the graphs of F and G intersect at 2 points, B and D. Right, so these are the points of intersection. How do you find the points of intersection in 5.3? So you're gonna look at f of x must be the same as g of x. What is f of x? It is minus into x minus 7 over 2. You square that. Okay, this is 7 out of 2, and then this is plus 81 out of 4 equals g of x, which is minus 3x plus 24. Okay, next, now we need to square this one. This is exactly minus x squared plus 7x plus 8, which is equal to minus 3x plus 24, which means that you have minus x squared plus 10x minus 16, and this is equal to 0. Let's find let's divide through by negative, which is x squared minus 10x plus 16 is equal to 0. So which means that at this point, you must be able to factor these out. Factors of x squared are x and x. And then now the factors of 16 that give minus 10, they are minus 8 together with minus 2, which means x is 8 or x equals 2. So what is x at D? Now the graph is drawn like that, so you can see that the D is the point here, and the B is the point there. I've made the graph a little bit smaller. So which means that x at the point D is the number 2, and we are actually done because D comes first. So that's like 2 there, and the next one is 8 because 8 is to the right of the number 2. And we have to calculate the value of A, the x coordinate of D. And that means, therefore, that the value of A is actually equal to the number 2. And we move to the next question, please. Right, so the next question now is this one here. If you have the two graphs of f and g, you have points A and B, the x-intercepts of f, and you have that there's a point S. And if the point S is there, is a point S that is sitting somewhere there with the coordinates X and Y. It's a point on the graph of F. Okay, F is this one, and the straight line is G. Right, and you have A is between, obviously, X lies between 2 and right, it lies between A and 8. Line ST is parallel to the y-axis. This is ST is parallel to the y-axis. I know this graph looks a bit smaller, right, with point T on the graph of G. Right, so you have point T is somewhere here, and the graph of G is the straight line graph. Determine ST in terms of X. Now, in other words, you have a graph like this, and you have another one like this, and you have this one and this one, you have S and you have T. So now we want to find the ST. So which means that ST is the same as f of x minus g of x, which is the same as what? What is f of x? F of x is this, all right? So it is exactly the same as x minus 7 over 2 squared plus 81 out of 4. minus the g is minus 3x plus 24. What is the answer to this? Okay, if you expand this, I know you might be getting tired. Please bear with me. I want to run through until I want to do all these questions. So this will actually become what? What is this squared? It's minus x squared plus 7x plus 8 minus, okay, if you multiply through here, it's going to be plus 3x minus 24. And then what is the answer? So this is minus x squared plus 10x. And so this is minus what? Right, so it's 10x and it is minus 16. Right, so you note that one, and we just remove and write the 0 clearly over there. And so now this is the number 0. So we have learned, therefore, that ST is this one. So what is ST? ST is minus x squared plus 10x minus 16, and that is the answer. Because we're to find ST in terms of x, ST now is an expression in terms of x written as an equation. Right, we move to the next question, please. Calculate the maximum length of ST. We recall that ST is the same as what? From the previous question, ST is minus x squared in that. So it is actually minus x squared plus 10x minus 16, which means you have dst dx, which is minus 2x plus 10. And so now we must equate this die here to 0. Okay, this is the derivative of this. You bring down the 2, you subtract 1 from the power. The derivative of x is the number 1. Right, from which we're able to see that 2x is equal to 10, which means x is 5. Okay, this x is 5. You want to find the maximum length of ST, so which means maximum ST is equal to what? Right, so you have this. So x is 5, which means it is minus, then you have 5 squared plus 10 into 5 minus 16. And then now when you calculate everything, you get that this is 9 units. And therefore, the conclusion is therefore that hence ST must be 9 units. Must be 9 units. So calculate the length of ST. So ST is actually equal to 9 units. Next question, please. Right, next question, we give an exponential function and it has a point there. And you need to write down the inverse and a couple of other questions. I've made space available on the next page to answer this question on the exponential graph. Write f inverse in the form that, right, first and foremost, you need to write the function f. So the function f is y equals 3 to the power x. Okay, this is the function f, which is f of x equals 3 to the power x. So f is 3 to the power x. What is the inverse function? The inverse function is you swap wherever there is y, you put x. Wherever there is x, you put y. And then you make y the subject, which means here you take the log of x, the base of these becomes the base here like this. Which means at this point, what is y? Y is actually the log of x base 3. And that is the answer. Next question. You need to write the sketch graphs of y and this on the same set of x's in your answer book, right? Let's look at that and look at that very carefully. Right, obviously indicate all intercepts with the x's. Right, would remember that the inverse function here, if f is this, the inverse function of x is the log of x base 3. We have the x-intercept. What is the x-intercept? To get the x-intercept of the graph, for example, you need to let y be 0. If y is 0, then you have the log of x base 3, which equals 0, which means x is 3 to the power 0, it is 1. Right, so x is 1 and y is 0, we have the 0.10. Right, simultaneously, what next thing do we get? So we must also be in a position to find the y-intercept. How do we find the y-intercept? To find the y-intercept, you let x to become 0. Right, so obviously at this point, we're looking at another function. So because now when y is 0 in here, if you put x equal to 0 here, so y-intercept is none. You write none like this because so when x is 0, the log is undefined. Log 0 is undefined on your calculator. Right, so we continue and therefore we can sketch the graph here. So this is the graph like this. This is the y-axis and this is the x-axis. A couple of things therefore remain very important. Okay, if you look at the graph of this here, it is like this. This is the graph of the log function, which is the graph of the inverse of f. It cuts through 1 here. And then now, if you say -2 is going to be this graph translated 2 units. If you subtract, it's 2 units to the right. 2 units right. So if it's 2 units right now, it is at 1 here, it's going to be there. It's at 1, you add 2. 1 plus 2 is 3. So at the end of the day, you have this here. Okay, so this is the graph of f inverse of x. This is the graph of f inverse of x minus 2, x and y. And then now here you have this one here, it's the inverse like this. So then you have the graph like this. Okay, so yeah. Okay, these are the graphs of the inverse of x and f inverse of x, and you have the intercept to the x's. So we are essentially done there. Next question, please. But also I must mention in passing that a student can also calculate the x-intercept. The x-intercept, right, so you can also calculate the x-intercept of the other graph here. Right, I did not calculate it because I know it's, if you can draw one graph, then if you subtract x, you can just move the graph to find the graph of the one that's translated by 2 units. But obviously another student can say, but say I can calculate the x-intercept of the new graph, this one. So which means if you find that this is a graph and you want to find the x-intercept, you let, for instance, y be 0. Right, so now in this graph here, how does this graph look like? Because this is f inverse. So if that is f inverse, it means that f inverse of x minus 2 is equal to the log of x minus 2. There's x, and you equate this to 0. Right, so yeah, there's 3. There's 3 here. So which means x minus 2, 3 to the power 0, which means therefore x is equal to 1 plus 2, which means x equals 3. Right, so obviously it confirms that the x-intercept of this inverse, f inverse of x minus 2 is going to be having an x-intercept of what? Of 3. Okay, so we are done. Use your graphs drawn in the previous question 6.2 to solve for x if this is the case. Right, so we remember the graphs are like this. This is the y-axis, and this is the x-axis. So this is a graph that passes through the inverse. This one here, it passes through 1, 3. Use your graphs here drawn in question 6.2 to solve for x if you have this one. So you have f of x. F inverse of x. This is the graph of the function f. So the inverse is the log of x base 3. So f inverse of x minus 2 would be the log of x minus 2 base 3. So which means that if this is less than, use your graphs to solve for x. If this is less than 1, right? So if this is less than 1, what do the graphs say? So in other words, you are saying y is less than 1 because the f inverse is like y less than 1 this. So where is y equal to 1? So you could have y equal to 1 like here, and then you put an open circle there, and there you put an open circle there, and you go like this. Okay, because it's strict, this inequality, so you put open circles because it's less. Right, so we're interested in the parts where this f x minus 2, f inverse of x minus 2 is less than 1, so it is less here. Okay, so if it is less than 1, what do we get? Right, so a couple of things that are very important, because if you look at the graphs, I would imagine that obviously these graphs have to be essentially as well drawn to scale, so that you can be able to see that you need to use the graph to solve for x. Right, what you must be able to see exactly what x is when y is 1 here on a grid paper. But since we have no grid paper, we shall solve this manually. And we shall say x minus 3 is less than 3 to the power 1 here, which means that x is less than 3 to the power 1 is actually 3. And then you add 2, which means you have a 5. But we agree, therefore, that at this point, you must also have that x minus 2 is greater than 0 because of what you call the domain restriction of the log function. We take logs of positive numbers, so whatever the argument is, it is called the argument of the log function. It must be strictly bigger than 0, which means x is bigger than 2. But x is bigger than 2. Simultaneously, you have this inequality. What is the conclusion? So you have, therefore, 2 and 5. X is bigger than 2, but x is less than 5. So where do they overlap? So the conclusion thus is that 2 is less than x less than 5. So we have exactly this part here. 2 is less than x and less than 5. Next question. The next question is about now the financial math, and obviously let's look at math of finance, the compound interest, and also annuity calculations. I know these are pretty straightforward, but we'll quickly run through a couple of examples that came in this year's preliminary paper. A survey conducted in December 2015 determined that 5.7 million South Africans were living with HIV. The researchers used the model of exponential growth A equals P into 1 plus I that to predict that there will be 6 million people living with HIV in 2022. Calculate as a percentage the annual rate of increase that the researchers used for the 7 years. Right. Obviously, we are looking at the annual rate of increase. So we use the formula with the plus for compound interest. So we use 1 plus I to the power n. Right. They are predicting that in 2022, there will be 6 million people. So you have a 6 with 3 zeros and another 3 zeros. And in obviously, we agree that in 2015, they did this projection and it was 5,700,000. 5,700,000 is like 5.7 million. 1 plus I to the power 7, and then it is 7 years. You divide everything, which is a 6 million. You divide everything by 5,700,000. And this is the same as actually here 1 plus I to the 7th power. Or you have the 7th root. If you divide 6 million by 5,7 million, you have 1,05 here, 26 decimals, which is 1 plus I. Right, so which means that we can be able to get the interest rate, which is 1,00 735 minus 1. Okay, check the seventh root of this, minus 1. Okay, so you get this one minus 1, and the result here is 0,00735. Right, so here we continue quickly, please. Right. Yes, please. But we continue now with the rest of the questions. Okay, so okay. Right. Yes, the double hole. Yeah, just give me some time, a little bit. Let me send you a message when because there's a project I'm just running to finish now with some students. Let me just send you a notification as soon as I'm done so that we can start. Okay. Yes, I'm just gonna give you a call as soon as I'm done so that you can come and you get started. But I don't want you to just come when I'm working on something else, because then you'll have to just wait and it's not fair. Okay, thanks. So I'm gonna give you a call as soon as I'm done, please. Okay. Okay, thanks, Itebuko. Goodbye. All right, chap. Okay. I want us to then continue and look at this one. We continue. We continue. We go on. All right. I was looking at this here. And then somebody just said to communicate with the student. So yeah, you have this here. So what does this mean? Well, it means the actual rate is R equals 0.74%. It means the actual rate is 0.74%. Okay, this is the rate that they want, because they said calculate the percentage as a percentage, the annual rate of increase. So the annual rate of increase is 0.74%, but also it's an increase because it's 1 plus I%. We'll continue. We'll look at more questions here. We continue. We look at more problems. Next question. Right, there's a guy called Shimi invests 4 million into an account, earning interest of 6% per annum compounded monthly. She withdraws 30,000 per month. Her first withdrawal is exactly 1 month after she deposited the 4 million. How many withdrawals of 30,000 will Shimi be able to make? Let's look at Shimi and the withdrawals that Shimi will be able to make. Okay, so at this point, because this one is an investment and it is money that is available now, we're going to use the present value formula. So present value is the same as x into 1 minus into 1 plus I to the minus n divided by the interest rate I. So which means that you have exactly 4 million, which equals 30,000 into 1 minus 1 plus. So you have 6% per annum is compounded monthly. So if it's 6%, you divide 6 by 100, which is 0.06. But it's monthly, you divide by 12. Okay, and it's raised to the power. You can raise it to the power n like this. Okay, or you can multiply this n by 12 as well. So yeah, and then you divide these by 0.06 divided by 12. So you're right, you cross multiply. So this is 4 million, right? And it is multiplied by right. So continue. Um, right. We continue. We continue. So now this is therefore 0.06 divided by 12. And it is divided by 30,000. And this is equal to 1 minus into 1 plus 0.06 divided by 12. You raise it to the power minus n. You divide the board, which means 1 over 3 is 1 plus 0.06 divided by 12. So you have minus n. Right, to solve for n here, let me take a Tenulo, which means that now I want to solve here. So this one, if it's like this, you take the log of 1 over 3 base 1 plus 0.06, you divide by 12, and it is like this, and it is minus n. So which means that n is 220.27. So the conclusion, therefore, is that she will make 220 withdrawals. You will make 220 withdrawals. Okay, she will make 220 withdrawals. So yeah, just note that one, huh? Note that one here. Okay, and then we continue to look at the next one. Right. She'll make 220 withdrawals that are full altogether. Next question. Because we're looking at withdrawals of 30,000. Because it is an investment, once again, of 4 million into an account earning interest of 6% per annum compounded monthly, she withdraws that and have 220 withdrawals. Next question. Right, next we're looking at 722. The story is the same about Shimi investing 4 million and she withdraws 30,000 per month. Right, how many withdrawals will Shimi be able to make if she changes the amount withdrawn per month to 20,000? Okay, so at this point now, we are still looking at the present value formula for the investment, and this is 1 minus into 1 plus I. Okay, so we continue. Right, we use this formula for the present value. We divide these by the by I. Right. So yeah, we can make this one shorter. It's a bit too lengthy. This division line from here and run just from here to over there. So it's 4 million. Which means it is 20,000 into 1 minus 1 plus 0, 0.06. Okay, so obviously at this point, you basically divide by 12 because it's compounded monthly. And you can raise it to n like this because n is unknown. So you divide this one by 0, 0.06 divided by 12. 0 is 1 plus 0, 0.06 divided by 12 to the power minus n. Okay, you see at this point, if you get all these, you will get this answer. So if you have this now, you simplify everything, it gets to this. If it draws 20,000, if you draws 20,000, then you will have, if you want to solve for n, to say how many withdrawals we're interested in finding n is equal to what out of these? Right. Right, so you will have exactly that. So what is the conclusion? The conclusion is that she can make any number which is an infinite number of withdrawals. Her interest. Now her interest end equals her withdrawal amount. You will only be withdrawing the interest amount. You'll only be withdrawing the interest amount. Okay, right. I mean, you want to solve for n and you get to this point. So the conclusion we make here is that she can make any number which is basically an infinite number of withdrawals. Right, her interest end equals her withdrawal amount. Okay, she will only be withdrawing the interest amount. Right, so just note that one there. Just note that one there. Note that one there. So we continue right now. We continue. Let's look at 7.3. Right, there is a Astrid opened a savings account with a single deposit of 1,000 on the 1st of April, 2022. She then makes 18 monthly deposits of 700 Rand at the end of every month. Her first payment is made on the 30th of April, 2022. Her last payment on 30th of September, 2023. The account earns interest at 15% per annum, but is compounded monthly. Determine the amount that should be in her savings account immediately after her last deposit is made on 30th of September 2023. So to do this question now, what are we asked to do? We need to determine the amount that should be in her savings account immediately after her last deposit is made, okay? Right, so first things first, at this point, we're gonna proceed as follows. We need to first determine the final amount. So A is P into 1 plus I to the power N. Right, remember she made a deposit of, Astrid made a deposit of 1,000. Right, 1,000 into 1 plus. Right, what is the interest? Right, the account earns interest at 15% per annum, but is compounded monthly. You take 15%, obviously you divide that one by 100, so it's 0.15. Okay, see, this is 15%, which is 15 per 100. You divide it by 12. Right, determine the amount that should be in a savings account immediately after her last deposit is made. So you have this one, which is exactly 18. Right, so obviously remember that she makes 18 monthly deposits of 700. So in other words, at the end of every month, now her first payment is made on 30th of April 2022 and her last payment 30th of September 2023. So the 1,000 now, after 18 months, will become exactly 1,250 Rand and 58 cents. Right, so that's what we get. So just note that one. What is the future value? So the future value is x into 1 plus I to the power n minus 1 divided by, this is the formula for the future value. We do substitutions, which means the future value. Remember that she makes deposits of 700 Rand into 1 plus 15%. So it is 0.15 divided by 12. Okay, there are 18 of these, so it's like 18 months because she makes like 18 monthly deposits, like 18 times. So just put the 18 here, right? So divide by this one here. Right, so you divide by the I, but also we agree that the I at this point is 0.15 divided by 12. Okay, I'm finishing this paper. So we have that this is exactly 14,032,33. Okay, in other words, if you make this deposit of 700 Rand, 18 of them, 700 Rand, 18 of them every month, her first payment due on the 30th of September, April 2022, and this is 2023, and this totals 18 months. The account earns interest of that compounded monthly. So this is the future value of the 700s. These 700s, after they've been deposited, they will actually become 14,000. So once they become 14,000, what is the amount? So the amount is the same as 1250,58 plus 14032,33, and therefore the amount is 15,282,91. Okay, so in other words, this is the amount, because determine the amount that should be in her savings account immediately after her first deposit. Right, immediately after her last deposit is made. So after the 18, so the 1,000 is going to become 1,250. The 700s, because they're made every month, you need to use the future value formula for them. But the 1,000 was just a once-off payment, so you need to use the compound interest formula. And then the 1,000 is going to become 1,250 and 58 cents. The 700s that are made, 18 of them, would become 14,032 rand and 33 cents. You add everything. So in other words, the amount that should be in a savings account immediately after her last deposit is made is 15,282 rand and 91 cents. Next question. Okay, the next thing is going to be really fast because I know this section is a very easy one for you. We are looking at calculus, which actually is about first principles and just the rules of differentiation and concave up and concave down functions. Let's look at the first one. Right. Given these functions here, we remember that the first principles formula, it is f primed of x, which is the limit as h approaches 0, which is f into x plus h minus f of x divided by h. Right, so this is the limit from first principles. As h tends to 0, and you have 3 into x plus h, you square this minus 6 minus into 3x squared minus 6, you divide everything by actually h. Okay, so we continue with the simplification of this here. And this is the limit as h tends to 0. Right, so this becomes 3x squared. We have the x squared term. The next one is 2 times x times h, which is 2xh times 3. It becomes 6xh. You have h, you square that, which becomes 3h squared minus 6 minus 3x squared plus 6. You divide everything by h here. So, which means we have the limit as h tends to 0. The x squared cancels out, so the 6 cancels out, and you have the 6hxh plus 3h squared, which divides h. So, which means you have the limit as h tends to 0 of 3h. And this is exactly the same as what? Okay. Right. We continue. Okay, I want to finish this paper. I know that I must see your brother Marang. So yeah, I'm gonna finish this paper and then I'm gonna take a short break for like, and then I'm gonna see your brother. Right. But I want to finish this paper because I want to have all the questions done in this recording. Right. So at this point, then you pull out 3h. When you pull out 3h at this point, what are you left with? You're left with only 2x, and here you have only h, like this. We divide everything by h. Okay, so this is the limit as h tends to 0. You have this plus h. Okay, but you see, as h tends to 0, it becomes 6x. That's the answer. And therefore, the conclusion is that at this point, we have that f primed of x is 6x. Okay? Um, So you have f primed is equal to 6x. And then now this is the actual answer to this question. We're done. Next question. Let's find the derivative of this one. This one can be done in multiple ways. At university, we use what we call the chain rule, because calculus is studied a lot at university for you guys to do BCom, accounting, and other things. But now we can do it here. So this is this. Right. In the exam, you need to first copy the question down. Ideally, if there's no answer book, if it is there in the answer book, then you don't copy it. Right? And then now you need to write this one out. So you square this. How do you square this? Right. You square 2. 2 squared is 4. You square this one, it becomes x. Then this times that, which is exactly minus 4 times the square root of x times 1 over x. Then you square this one, which becomes plus 1 over x squared. So this is f of x equals 4x minus 4x to the minus 1/2, and then it is x to the minus 2. Which means you have f primed. The derivative of the 4x becomes only 4. Here you bring down minus 2, minus half times this is actually 2x. Subtracting 1 is minus 3 over 2. Bringing the minus 2 down is minus 2x to the minus 3. Right, which can be written normally. You need to write your answer with positive exponents if time allows, but you need to be very fast. So which is actually 2 here. And 2 can be divided by x to the 3 over 2 minus 2 over x cubed. This can also be written as 2 divided by, you have x cubed minus 2 divided by x cubed. Okay, so that becomes sort of the answer. And we are done with this question. For just 5 marks only. Next question, please. We have found the derivative of this function. And that is the correct answer. Next question. Right here, now we need to determine the interval for which f is concave up. Right, so we have f of x, which means it is 3x cubed minus 3x squared plus 6x minus 2. Okay, now you find a prime. What is 3 by 3? It is 9x squared minus 6x plus 6. Right, so when they say determine the interval for which f is concave up, we need to find the second derivative, which is exactly the same as 18x minus 6. Right, so for concave up, what do we mean by concave up? By concave up, we mean that by concave up, we actually mean that the second derivative itself is greater than 0. We mean that the second derivative is bigger than 0, which means that 18x minus 6 is bigger than 0, which means that x is bigger than 6 out of 18, which means that x is bigger than 1 over 3, which means x is an element of the interval from 1 over 3 to infinity. Okay, that is the answer there. The interval over which, or the interval for which f is concave up, the interval is from 1/3 to infinity. Next question. Right, here also there are more graphs that you need to understand. But now here, sometimes they can give you the graph, like sketch below is the graph of f prime. So they can give you the graph of the derivative and ask you to find some points, some coordinates, and so on. Let's understand and answer the question that follows. Right, sketch below is the graph of f primed. So this graph here is the graph of f primed, the first derivative. So they have this function here and they have differentiated. They found the first derivative or the derivative of this, and then they drew the graph of the derivative. Points A, B, and C are the intercepts of f primed with the x's. So we continue. Write down the coordinates of A, which is the exact x-intercept, or rather y-intercept, okay? How do you find we need to write down the coordinates of A. So to write down the coordinates of A, we then obviously proceed as follows. We copy down the function original, which is minus 2x cubed minus 3x squared plus 12x plus 20. We find the first derivative, which is minus 6x squared minus 6x plus 12. Right. What is then the y-intercept? To get the y-intercept, you let x be 0, because this is the graph of f primed. So which means that you're going to have then f primed of 0, which is minus 6 into 0 squared minus 6 into 0 plus 12. Then what is the answer? The answer is 12. So the coordinates of A are, here you have that x is 0 and x is 0 and y is 12. Right, so A has coordinates x0, x0, and y12. So that is the answer. Okay, next question. Okay, the information above is the same, but we want to determine the coordinates of B and C. So B and C, we can see this is actually B, and this is actually C, and that is A. And this is F primed. How do we find the x-intercepts? Right, so we are finding the x-intercepts of F primed, which means that you have f of x cubed minus 3x squared plus 12x plus 20. So you find that the prime here, minus 6x squared minus 6x plus 12. Okay, right, this is the thing. So now to find the x intercepts of f primed, you let f primed of x be equal to 0. Which means that it is x squared plus x minus 2 equals 0. Which means that it is x plus 2, x minus 1 equals 0. Which means x is minus 2 or x equals 1. What are the coordinates of B? X is minus 2 and y is 0 on the x-axis. But also we have that the point C would have the coordinates x is 1 and y is 0. Minus 2 and 0, 1 and 0. Right. So now we have found the coordinates of B and C, which are the x-intercepts. Next question. Which points are on the graph of F will have exactly the same x values as B and C? Right. Remember that At this point, if you want to find which points on the graph of f, we're referring to the graph of f. Remember that this is the graph of f prime of x. This is the equation of the function f. Which points on the graph of f will have exactly the same x values as b and c? What are the x values at b and c? Right, we found -2 and 1 respectively. So we found -2, 0, and then we found 1, 0. So now we are asking the x values here, which points on the graph of f will have exactly the same x values as these b and c? They are the turning points. The turning points. Because here we got the x values of the turning points on f. Turning points on f. Turning points on f. (9.1.3). Which point on the graph of f will have exactly the same x values as b and c? The turning points. That's the answer. Because these are the turning points, b and c become the turning points of the graph of f. They're not turning points here because this is the graph of the first derivative. But b and c are turning points of the original function, f, whose derivative has been sketched here. 9.1.4. For which values of x will f be increasing? Okay, f is increasing when the derivative is positive. So which means you have f of x minus 2x cubed minus 3x squared plus 12x plus 20. And then you find the first derivative. Minus 6x squared minus 6x plus 20. Okay, this is the slope, and this is positive. So here you already know you have -2 and 1 here. So where is this derivative positive? This increasing. So it is positive here because it is 0 here. That's why I'm removing this. It's 0 if the graph is 0, but it's positive here. So I'm putting the open circles to sort of exclude these extreme points. So which means, therefore, at this point you have -2 is less than x less than 1. Right, so these are the x values for which it is f is increasing. It's increasing between -2 and 1. Right, so we have that. The next question, please. Right, I must indicate you can write your answer like this, or you can also write x is an element of the interval from -2 to 1. From -2 to 1. 9.1.5, what is the point of inflection? Right, the point of inflection will be the derivative of this. So now they said determine the y coordinate of the point of inflection of f. Okay, let's look at the point of inflection. Right, the point of inflection. Which means that you're going to find f primed of this, which is -6x squared minus 6x plus 12. Then you find the second derivative, which is -12x minus 6. and this is equal to 0. Right, and this means that we have minus 12x is equal to 6, which means x is minus 6 out of 12, which is minus 1/2, like this. So we continue. So that we have f of x you have this here plus 12x plus 20. And then we substitute, we want to get the y value. So that happens at x equal to minus 1/2. So you square this. Plus 20. So this is 13,5. Okay, they start determine the y coordinate of the point of inflection. It is the y coordinate of the point of inflection is 13,5. The y coordinate of the point of inflection. So, okay, this is the x value of the point of inflection. The y coordinate of the point of inflection is 13,5. Next point. I'm finishing, please, guys. I know you've been here for a little bit long. Okay. Right, so you have this. The tangent P to the graph is given by this. Intersects the x-axis at point R. Right PT or line PT is drawn perpendicular to the x-axis with P on the x-axis. Determine the length of RT. Okay, so there was an issue with this question in the exam. So this question was removed from the exam paper. But it's very interesting to understand the question. So I'll just analyze it with you. F is this one, which is minus 2x cubed minus 3x squared plus 12x plus 20. Then now you find the derivative of this because you are looking at the tangent at any point. Okay, because if you're looking at the fact that the tangent at P to the curve is given by this. Intersects the x-axis at R. The line PT is drawn perpendicular to the x-axis with P on the x-axis. Determine the length of RT. Okay. This is the original, well, you're given the function f in the question, but this one, the tangent at P to the graph is given by this. So this is the tangent, which is y is minus x squared minus 1. Okay, the tangent is not straight. Right, so the question had a couple of issues there because at metric, normally we do tangents that are of the form y equals mx plus c. So the tangent is this. Right, so if you look at the fact that the tangent at this, let's substitute this to see if this point makes this true. So if x is 3 here, you put 3 squared is 9, minus 9 minus 1 is minus 10. Okay, so yeah, this point indeed satisfies this tangent because the tangent at this point to the curve is given by this. Now intersects the x-axis at point R. So now this intersects the x-axis. So if you look at the x-intercept, so there is an x-intercept. So at the x-intercept, you let y be 0. which means it is this one minus that equals 0, right? What is the x-intercept of this one here? So you have minus x squared equals 1, which means x squared is equal to minus 1. Okay, no real roots. X squared is greater or equal to 0. No real roots. So intersect the x-axis at the point R. So it's not, this one does not, yeah, because the tangent at this point to the graph is given by these. Intersects the x-axis at the point R. So this one does not intersect the x-axis. This one does not. The examiner had made a mistake here. Does not intersect, does not intersect the x-axis. Okay, does not intersect the x-axis. Okay, if it doesn't intersect the x-axis, it means a couple of things. Because this graph here, if you draw the graph of these, how does the graph look like? When x is 0, okay, so it's gonna, actually when x is 0, y is minus 1. Forgive me, please, I just went. I think I'm somewhere here. Okay, I'm somewhere here. My apologies, I just pressed another button. All right, so I'm effectively saying the graph to this is gonna be like these through minus 1. Okay. Okay, so it does not cut the x-axis, right? It does not intersect the x. So the examiner had said the tangent at this point to the graph is given by this intersects the x-axis at R. It does not intersect the x-axis. So, Mr. Examiner, y equals minus x squared, that does not intersect, the x-axis. Okay, I'm gonna finish, please, guys. The x-axis at R. At any point, it doesn't. Okay, so the examiner was wrong here. They made a mistake somehow. But line PT, okay, this is the graph of the thing, of the tangent. If you draw the tangent, the tangents normally are straight, but yeah, the examiner brought a curved one. Line PT is drawn perpendicular to the x-axis with T on the x-axis. Line PT is drawn perpendicular to the x-axis with T on the x-axis. Determine the length of RT. Okay, the examiner was really saying if ever it was cutting, it would intersect maybe the point R, and there's T. All right, with T on the x-axis. Right, so you would have T on the x-axis, but it would have to intersect somehow at the point R. Right. R somewhere there. And then you would have to find the length of RT. Okay, so yeah, there was a mistake in this question, and this question obviously was removed from the paper. I'm sure that the guys who wrote this paper were made aware of the removal of this question because it lacked the mathematical logic that is required. Next question, please. Okay, I made space available for it, but yeah, we've concluded this question. Right, question 10 was also brought to this paper here, and let's look at this one. Profit. Let's calculate the profit. Profit WX earned by a company to manufacture X bicycles per week is given by this. What should the weekly bicycle production be to maximize the profit? So it means that you would find W primed. Bring down the 3, so it's minus 3x squared. The 150 is much of a constant. The 3x squared, you differentiate it, it becomes 6x. The minus 250x becomes this. You equate it to 0. So we're using what should the weekly bicycle production be to maximize profit? So you do this for max, for maximum profit. Right. So if you simplify these, then it becomes, in other words, you divide through by 3, multiply it through, so it becomes minus x squared plus 300. X minus 125, 0, 0. Okay, x squared minus 300, x plus 125, 0, 0 equals x. Okay, button was just pressed. The factors of x squared are x and x. Then you have the factors of 12,500. What are the factors of 12,500? They are minus 250 and minus 50. So this is 250, x equals 50. What should the weekly bicycle production be to maximize profit? Right, so let's analyze this together. You would need the W primed, which is minus 3x squared divided by 150 plus 6x minus 250. So this one is minus 6x over 150 plus 6, right? Because you bring down 2 times minus 3, minus 6x plus 6, okay? The second derivative of the W primed is, then write it as minus x. 150 divided by 6 is 25 plus 6. Right, so what should the weekly bicycle production be to maximize profit? So you want the profit to be maximum. So we're gonna look at the two situations. We're gonna substitute at these things here. Okay, we can, in other words, we're deciding to use the second derivative, or we can use the first derivative. So we are at liberty to use whatever one, but I'm just using the second derivative. So just to note that to maximize, you can also use the first derivative to maximize. But this one is easier because this function is small. There's fewer terms. So if you use the second derivative, it's going to be double primed of 50, which is minus 50 out of 25 plus 6, which is minus 2 plus 6. And this is 4, and 4 is bigger than 0. Let's also look at, substitute 50. Let's substitute 250 as well into the place of x, double primed of 250. It's going to become minus 250 out of 25 plus 6. So 250, if you divide this one, it gives minus 10 plus 6. And what is this? It's minus 4. Okay, minus 4 is negative. It's less than 0. So this is minus 4, which is less than 0. Okay, I'm going to finish, please, guys, quickly. We're finishing the whole paper now. Just the last maybe 2 questions left, up to question 12. Right, so this is less than 0. So where does the maximum profit occur when you're using the second derivative, please? The maximum profit? Maximum profit is 250. 450 bicycles. $450 bicycles weekly. Right, so the maximum profit is going to be actually, so the maximum is going to be occurring at 450. You're able to see that because the second derivative is what? It's negative, meaning we have a maximum at 250. So that is just one way to analyze this question using second derivative. But you can also take this, because this is the first derivative, then you can just substitute into this and see which one is maximum. But just that if you put 250 and you cube it, it becomes very large in the 50 part. Yeah, what should the weekly bicycle production be to maximize profit? It must be 250, because at 250, the second derivative, W double primed, the W double primed is negative, meaning you have the maximum profit of 250 bicycles weekly. Let's look at the next one. Okay, in question 11, now we are looking at machines and we're looking at probability. Let's just quickly do probability. It's one of those sections where you need to get 100%. Very, very straightforward. Machines A and B, and we're looking at the events A and B, etc. And I've made enough space available on the next slide for me to solve this problem. Right, so machine A and machine B are two different coin processing machines that operate at the same time. The probability that machine A only presses a 5 coin is X. And the probability that machine B only presses, these are coin pressing machines. Let me read this again from the beginning, please. Machine A and machine B are two different coin pressing machines. They're pressing machines that operate at the same time. The probability that machine A only presses a 5 rand coin is X, and the probability that machine B only presses a 5 rand coin is 0.3. The probability that both the machines press 5 rand coins at the same time is 0.1. If A and B are independent events, determine the values of X and Y. Okay. Okay, if A and B are independent events, determine the values of X and Y. Okay, we're looking at A and B as independent events, which means for independent events, we proceed as follows. For independent events, you would have that the probability of A and B is the probability of A times the probability of B. So what is then? Okay, this is sort of the diagram we have. Right, so what is the probability of A and B from the diagram? The probability of A and B is 0.1. The probability of A is X plus 0.1. X plus 0.1. This is multiplied by the probability of B, which is exactly, probability of B is 0.1. plus 0.3. Okay, if you want to find the probability of B, is 0.1 plus 0.3. So which means that it is 0.1, which is x plus 0.1. And then this one is 0.4. 0.1 divided by 0.4 is x plus 0.1. This means x is, okay, if you divide these two guys here, they are 0.25. So yeah, this is 0.25 minus 0.1, which means x is 0.15. Right, if A and B are independent events, determine the values of x and y. So in other words, we've already found that x is 0.15. What is y? Right, to get y, we need to add everything here. So that is going to be x plus 0.1 plus x plus 0.1 plus 0.3 plus y, which is outside. And it's like everything. 0.15 plus 0.1 plus 0.3 plus y equals 1. And this is exactly 1 minus everything is 0.45. So y is 0.45. So that's the answer to this question. So y is 0.45. Right, so we've got that x is 0.15, and we got that y is 0.45. Next question about this probability. Determine the probability that exactly one of the machines is pressing a 5-rand coin. Right, so a couple of things here remain very important to remember, that x is from the previous question is 0.15 and y is 0.45, and the probability that exactly one of the machines is pressing a 5-rand coin, that would mean therefore that if they say, so it's either it's x plus y, x plus 0.3, excuse. Okay, look, because now if exactly one of the machines, so it's either A or B, but not both. So you're gonna take the x here and here. If it's only A, then it's x, but it's only B, 0.3. So it's either x or 0.3, x plus 0.3. What is x? Is 0.15. What is the other one? Is 0.3. So this is 0.45. Right, so what is the probability in 11.1.2 that the probability that exactly one of the machines is pressing a 5-rand coin? It is 0.45. Next one. Wilson takes a driver's test. The probability that he will succeed on his first attempt is 3 out of 7. Right, so for each attempt that he redoes the test, the probability of passing increases to 3 out of 5. What is the probability that Wilson will succeed after 2 attempts? right, determine the probability that Wilson will succeed after 3 attempts. So we look at this question. I've made space available for this question. So Wilson, obviously, you understand in question 11, takes a driver's test, and the probability that he will succeed on his first attempt is 3 out of 7. For each attempt that he redoes the test, the probability of passing increases to 3.5. What is the probability that Wilson will succeed after 2 attempts? So here we're going to say, first things first, we proceed as follows. Right, so this question here considers exactly 2 things. So we look at Wilson. Either Wilson fails the test or passes, you know. Either they pass, or either Wilson passes or fails. Okay, remember the probability that Wilson will succeed after 2 attempts. Second attempt, he can either fail or pass. All right, so Wilson take the driver test. So here we're using a tree diagram to solve this problem. So the tree diagrams are very important. The probability that he will succeed on his first attempt. So the probability of passing is 3 over 7. What's the probability of not passing? It must be 4 over 7 because 4 plus 3 is 7. 7 over 7 is 1. The total probability of either passing or failing must be 1. So the probability of failing is 4 over 7. For each attempt that he redoes the test, the probability of passing increases to, if he redoes, it increases to 3 out of 5. If he redoes, then, right, the test, the probability of passing increases to this. Right, so the probability of passing becomes 3 out of 5. And then if you fail, the probability of failing becomes 2 out of 5 because 2 plus 3 is 5 out of 5. So this can continue. If he does for the 3rd time, he's gonna either pass or fail. But the probability of passing is 3 out of 5. Good. Right, so we have these questions here. What is the probability that Wilson will succeed after 2 attempts? Okay, so the probability that Wilson succeeds after 2 attempts, right, success, okay, probability that Wilson will succeed after 2 attempts. So let's look at that very, very carefully. Right, let's look at these very, very carefully. Probability that Wilson will succeed after 2 attempts. Okay, because we know that the probability of him failing is going to be 4 out of 7, because the probability that he will succeed on his first attempt is this. So you have that. So the probability that Wilson will succeed after 2 attempts would be what? So after 2 attempts, it can be that Wilson will fail. Wilson will fail first. Will fail first and then pass second time. And therefore, 4 by 3, it's 12 out of 35. So, I mean, if it's after 2 attempts, he can fail and then pass second chance. And then now that's the probability of him succeeding after 2 attempts. Next question. Determine the probability that Wilson will succeed after 3 attempts. Right, I drew the tree diagram. So after 3 attempts, okay, I'm going to quickly redraw it again. So you have this here. Either Wilson fails or passes. The probability of him passing, probability that he will succeed, first attempt is 3 out of 7. And then here it is 4 out of 7. And then here is the probability of second chance, he can fail or pass. But for each attempt that he redoes the test, the probability of him passing increases to 3 out of 5. So it's going to be 3 out of 5, and this is going to be 2 out of 5. Now this one here is going to be fail pass, 3 out of 5. Okay? Look, the probability that Wilson will succeed after 3 attempts, right, would be what? Okay, if he succeeds exactly after 3 attempts, it would mean a couple of things. It would mean a couple of things. Okay, just look at a rough tree diagram there. It would mean that the probability that Wilson succeeds after 3 attempts, it would mean 4 out of 7. 4 out of 7, he fails. Then 2 out of 5, he fails. Second time, he fails. He fails first time, second time he fails, third time he passes. 3 out of 5. And if you multiply everything, 4 by 2 by 8 is 24 out of 175. So we're looking at determining the probability that Wilson will succeed after 3 attempts. Next question. Okay, the next question is the last question out of 150 marks left, just with a few minutes to finish the paper. When Marge turned 8, her friends Emily, Clara, Corey, Lisa, Shelley, and Penny were invited to a birthday party. Marge and her friends sat in a row and played a game. In how many ways can they be seated if they sit in alphabetical order? 1 mark. Let's look at the question on the next page. I've broken it down to pieces. Right. So obviously agree that we have when Marge turned 8, her friends Emily, Clara, Corey, Lisa, Shirley, and Penny were invited to a birthday party. Marge and her friends sat in a row, played a game. In how many ways can they be seated if they sit in alphabetical order? Obviously, these are not in alphabetical order because there's E, then K, then C, so they're mixed up. Right. So in how many ways can they be seated? So let's agree. We have this. Right. We have exactly this. So when Marge turned 8, her friends Emily, Clara, Corey, Lisa, and okay, we're seated. Now, Marge and her friends, okay, this Marge and her friends sat in a row and played a game. So if they, so they sat all of them in a row and then they played a game. So obviously, how many are they now? You have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So you have merged here. Okay, merge can sit anywhere. Right, okay. But now let's first organize this in alphabetical order. Which one is first? Because the examiner wants it in alphabetical order. So I just want to discuss this a little bit too. Right, in alphabetical order, which one is first? P is first. So in other words, would have Corey. So we are done with Corey. Then Emily. Right, then we have Emily. Right. And then now you have the next one. Oh, yes, we've done with Emily. And then you have K, Clara. We're done with Clara. KL, Lisa. Right. M is Marge. PQRST, Penny, and Shirley. All right. So you have this. Okay, in this order, so in alphabetical order, so there's this one, because their position is already here, they can be there in one way. One way, one way, one way, one way, one way, one way. So, which means that determine the, in how many ways? One way, one way, one way. So it's 1 times 1 times 1 times 1 times 1. So this is the number of ways. Right, so the number of ways here is 1 times 1 times 1 times 1 times 1 times 1 times 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8. How many did we have here? 1, 2, 3, 4, 5, 6, 7. I need to remove 1. Okay, so we write back. 2, 4, 6, 7. So these are exactly, it's exactly one way. One way, I mean. I've written one ways with you. It's only one way. It's not that. Obviously, we're saying they sit in alphabetical order. They can actually sit in one way. But I must indicate that this question will have in alphabetical order. Alphabetical order, we mean A, B, C, D. That's alphabetical order. But also, I want to look at another dimension to this question. Corey can sit here, Emily sit here, I can sit here, then Clara, then Lisa. So you can look at the fact that either we start from here or either we start from the left or we start from the right in alphabetical order. So you can look at the fact that the number of ways would be this one way or one way in reverse, which could be in two ways. Okay, because if it's an alphabetical order, or you can say, okay, alphabetical order, I sit here, then Emily, then Clara, then Lisa, then they play the game. When Marge turned 8, remember those who are 8 years old, they are still like in grade 3. And in grade 3, they want to play a lot of games, and they played a game. So now Corey could either sit at the beginning or Corey could sit there. Could start from the left or start from the right, and then the others follow. So you can look at this question as a two-way approach to say there are actually two ways there. But If you look at the fact that alphabetical listing begins from A, B, C, D, you can look at it as obviously giving you one way in the standard alphabetical order listing. Okay, next question. So in the marking of this exam paper, both answers here were marked right. Both answers were acceptable if a student will say, okay, we look at alphabetical listing and there's only one way of arranging them beginning from A, B, C, D up to Z. Okay, ordering them according to the letters that are here, Corey, Emily, and so on. Okay, so they gave full marks for the one way, but also there's another dimension says the truth is they can see it either this way or the other way, giving us a total of either one way or in probability theory, say, or you add two ways. Okay, the same story is the same. Emily and Clara do not want to sit next to each other. All right, so let's look at this one here. I need to start again. How many? Okay, 1, 2, 3, 4, 5, 6, 7. Yeah, with 7 with Marge. So I'm just putting some blanks. I need to just make sure that this makes a kind of sense as required. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. Right, we're done, guys. Just about one question left, and then you can breathe. But now here, we want to organize them in alphabetical order. I'm going to put them at the bottom. We start with Corey. Then we have Emily. Then we have Clara. Then we have Lisa. Then we have, that is KLM with Marge. Then we have, yeah, MN or PQR. We had Penny and then Shelley. That's correct. Then Shelley. Okay. Okay, let's look at these. Emily and Clara do not want to sit next to each other. Emily and Clara. Okay, obviously, if we that to sit in alphabetical order, they need to sit next to each other. But these guys do not want to sit next to each other. So we must separate them because maybe they are, sometimes some kids, so one kid says, Emily can say, I don't want to sit next to Clara. I want to sit next to somebody else, but not next to Clara. No, Clara is teasing me. Clara is doing this and that. The kids play. So let's analyze this question now. The number of ways of organizing all these people, if they sit if they sit in that order, you'd have to therefore say 1, 7. So for the first arrangement, we have 7 choices. To actually choose the one to be placed here. Right, so if we take 7 choices to place somebody there in a general listing, such that now we are mixing the order. Now we are mixing the order. We are mixing the order. So if we mix the order because these two guys do not want to sit next to each other because they're teasing each other, they're fighting with each other. So yeah, 7 choices here. Then we have 6 choices. 6 choices here. All right. 7 choices here. Then you have 6 choices here. I mean 6 here. Yeah, I read 7 twice, but I mean 6. Okay, just note that. 6 choices here. Then here you have 5 choices. Okay, because now we are mixing the people. Then we're looking at all arrangements. These are like all arrangements. Right, we're looking at all arrangements. We're looking at all arrangements. So yeah, 4 choices, 3 choices, 2 choices, 1 choice. Up to 1 choice. Okay, you are mixing them up. So here we are mixing up. We're mixing up the people. So which means that if we're mixing them up here, there are 7 factorial ways of ordering these. It's 7 times 7 factorial is 7 times 6 times 5 times that. Is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. Okay, now these guys who don't want to sit next to each other, Emily, they don't want to sit next to each other. So we can order them in 2 factorial ways because there are 2 of them, 2 factorial ways. There are 2 of them, but we need to like decide that, okay, we put Emily here and we put Clara here so that the others can be in the middle. Okay, once we take Emily and Clara, then we're left with 1, 2, 3, 4, 5, then 6. They must become. Where do we here? Okay. Yes, there are 5. 1, 2, 3, 4, 5, because they're 7 altogether. But remember that once we look at the fact that we have 1, 2, 3, 4, 5, then we have 5 plus these guys that would have organized. And those ones now, they give us, we can organize them in 6 factorial ways. And therefore the answer here becomes 3,600. If you use a calculator, 7 factorial minus 2 factorial times 6 factorial, which is 3,600. Next question, please. Last question. The probability that a certain rugby team has all its players fit to play is 70%. The probability that they will win a game if all their players are fit is 90%. When they are not fit, the probability of them winning becomes 45%. Calculate the probability of them winning the first game. The probability of a win for the rugby guys. The probability of a win, the probability that a certain rugby team has all its players fit to play is 0.7. So it means that you have 70 over 100 times the probability that they will win a game if their players are fit is 90%, 90 over 100. When they are not fit, the probability of them winning becomes what? Okay. I want to analyze it as follows. First things first. The probability that a certain rugby team has all its players fit is 70%, and the probability that they will win a game if all their players are fit is 90%. Or they will win if this is the case, or the following. or the following. When they are not fit, the probability of them winning is 45%. So we're going to look at 45%, which is 45 over 100 when they are not fit. When they are not fit. Okay. But there's a chance of winning. The probability of them winning is this. But also now you'll have to consider the probability that a certain rugby team has all its players fit is this one. So, but here when saying when they're not fit, so the probability of them being not fit is going to be 70 minus 100 minus 70 is 30%. 30 per 100. So which is 0.7 times 0.9. 0.3 times 0.45. The probability of a win is 0.765. And this probability is like 76.5%. So this is the probability of a full win. So yeah, we calculate the probability of them winning the first game. The first game. So it is 76.5%. Right, so this is the end of the question paper. This is the end of the trial paper. Right, thank you guys for joining us. It's 17 past 5. I can't believe that you have taken a bit more time like this. Okay, so it's like 17 past 5, and I will see you guys again when okay, so you think about it. We can meet again later at about 8:30 if you have, yeah. You're gonna let me know if it have 8. You can join or watch. But yeah, there's another discussion I'm planning at 8:30 tonight. So yeah. Otherwise, thank you guys for joining us. I'm gonna pause this video in the next couple of minutes. I'm gonna be back again at 8:30. I'm gonna open the platform for anyone. I'm gonna be looking at more IEB questions, paper 1. I'm gonna be looking at a full paper review and specific sections and questions that we can just solve and discuss. But yeah, it's going to be an open debate so that I can get your questions. Yeah. But thanks a lot. I'm going to pause this video in the next couple of minutes. Thanks, guys. Goodbye for now. Have some time to drink water and chill. Thank you. Goodbye.